So when we have an equation in the form of r squared is equal to x minus h squared plus y minus k squared, that's actually called standard form. We can easily identify the radius and the center from an equation like that. But sometimes we might have an equation in this format, and we will not be able to identify the radius or the center from that type of equation. This is called general form, and so we would need to get general form into standard form. So there's a couple of review things that we're going to need to do in order to be able to efficiently take a circle equation from general form and turn it into standard form. The first thing that we need to do is we need to figure out or talk about perfect square trinomials. A reminder that a perfect square trinomial is when you can take the square root of your first and last term. And when you take the square root of your first term and your last term, if you multiply these together and then multiply them by 2, you should get your middle term. A 3x times a 2 does give us a 6x. So this is a perfect square trinomial. And in order to factor these, what you would do is you would just take the square root of your first term, which is x, the square root of the last term, which is 3, and the operation in between my first and second term, which is a plus, and then you square it. This is x squared plus 6x plus 9, fully factored. So for the next one, same thing. Square root of my first term is x, square root of my last term is 6, and you take the operation in between your first and second term, and then you square it. My next one, square root of my first term is x, square root of my last term is 4. And then you take the operation in between your first and second term, which is a minus, and you square it. So number 17, sometimes general form is already in the perfect square trinomial format, and we can just go ahead and write the equation of our circle by taking the square root of our first term, taking the square root of our last term, and the operation in between my first and second term, and squaring it for the x values. Then taking the square root of my first term for the y values, square root of my last term for the y values, and the operation in between my first and second term for the y values, and squaring it, and then just leaving the 25 alone. Now, my center for this one would be 1, 2, and my radius would be the square root of 25, which is 5. That one is simple because my x part and my y part were already in perfect square trinomial format. Now there's some that are not going to be in perfect square trinomial format. However, in number 18, A and B, both of these are in perfect square trinomial format. So we're going to go ahead and get started with writing the equation. Take the square root of our first term, square root of our last term, operation in between my first and second term, square it, drop down this plus sign, take the square root of my first term, square root of my last term, operation in between my first and second term, square it, and then drop down the equals 36. This is my equation of the circle. Next one, square root of my first term, square root of my last term, operation in between my first and second term, square it, bring down this plus sign, square root of my first term, square root of my last term, operation between my first and second term, square it, and then drop down the equals 4. This is my circles equation. Now, the ones on the next page are not in perfect square trinomial format. So we're going to have to do completing the square, which is something that we did in algebra. We're going to review completing the square in number 19 before we jump back into circle equations. So let's go ahead and let's review how to complete the square. The first thing we do with completing the square is if our coefficient of x squared is not 1, then we need to divide by whatever number it is. Fortunately for us, in A and B, the coefficient of x squared is 1. So then the second thing that we do is we move the constant to the other side of the equation. So subtracting 13 from both sides, I get an x squared plus a 2x is equal to a negative 13. Now on the left side, I want to make this into a perfect square trinomial. How I do that is I take my b value, I divide by 2, and then I square that number. A 2 divided by a 2 is a 1 squared is a 1. So then what I do is I add that 1 to both sides of my equation. I need to stay balanced. Now I factor this perfect square trinomial, which we did up in numbers 14 through 16. So I take the square root of my first term, square root of my last term, operation in between my first and second term, and I square it. And on the right side, I just simplify. A negative 13 plus a 1 is a 12. So actually, this is as far as we're going to get with the circles. But when I ask you to factor by completing the square, you actually go further. And you do solve for x by taking the square root of both sides. And we get an x plus a 1 is approximately equal to a positive or negative 3.46. And then we subtract 1 from both sides to get x is approximately equal to a 2.46 and a negative 4.46. Now that's how we finish off completing the square. But again, with circles, we're going to actually stop at this point before we take the square root of both sides. All right, let's review again completing the square with letter B. I'm going to first get my constant to the other side, all my constants to the other side. So I have an x squared minus an 8x is equal to a 3. On the left side, I'm going to turn this into a perfect square trinomial. So I take my b value, I divide by 2 and I square it. A negative 8 divided by a 2 is a negative 4, and a negative 4 squared is 16. I add that 16 to both sides. So then I factor my perfect square trinomial on the left, take the square root of the first term, square root of the last term, the operation in between my first and second term, and square it. And then on the right, I just simplify. When dealing with circles, we would stop at this point. But since the directions for number 19 say to complete the square, we would need to go further here. I would take the square root of both sides to get an x minus 4 is approximately equal to a plus or minus. The square root of 19 comes out to be approximately a 4.36. I would then add 4 to both sides to get x is approximately equal to an 8.36 or a negative 0.36. Okay, so let's now do this with circles. So for letter A, my coefficient of x squared and y squared are 1. So we can start by adding all the, or getting all the constants to the other side. The only constant I see is this 8, so I'm going to add it to the other side. So now I have an x squared plus a 4x. I'm going to leave a little space, plus a y squared minus a 2y. I'm going to leave a little space, is equal to 8. Now for the x part and the y part, we do need to create two perfect square trinomials. So for the x part, I take my b value of 4, I divide by 2, and I square that number. A 4 divided by a 2 squared is a 2. Sorry, 4 divided by a 2 is a 2. A 2 squared is 4. And I add that to both sides. Then I do the same thing with my y value, my y side. I take my b value, I divide by 2, and I square it. A negative 2 divided by a 2 is a negative 1. A negative 1 squared is a positive 1. I add that 1 to both sides. Okay. From here, I factor both of my perfect square trinomials. For the x side, I take the square root of x and the square root of my last term, which is 4, and the operation in between my first and second term, and I square it. For my y's, I take the square root of my first term, square root of my last term, operation in between my first and second term, and I square it. And then on the right side, I simplify. So I have an 8 plus a 4 plus a 1, which gives me a 13. This circle equation is now in standard form, and we just stop there. So we don't go all the way with completing the square. We stop once we get to the circle format equation. Now letter B is a little bit different because my coefficient of x squared and y squared are not 1, and they need to be 1 in order to do this. So I do need to divide this entire equation by my coefficient of x and y squared, which is 2. So I wind up with x squared minus 8x plus y squared plus 10y is equal to negative 10. Now I already have my constant on the other side. So I'm actually going to rewrite this equation to give me a little space. So I'm going to have a space here. And I'm going to have a space here because I want to create two perfect square trinomials. So let's get started. For the x side, I take my b value, I divide by 2, and I square it. A negative 8 divided by a 2 is a negative 4, squared is a 16. And I add 16 to both sides. For my y side, I take my b value, 10, divided by 2, and I square it. 10 divided by 2 is a 5 squared is a 25. I'm going to add it to both sides. Sorry, I didn't add the 16 yet to the other side. There we go. All right, then from here, I factor my two perfect square trinomials. The square root of my x side, the square root of my first term is x. Square root of my last term is 4. My operation between my first and second term is a minus. And then I square that. I drop down my plus sign between my x part and my y part. And then I take the square root of y squared, which is y, the square root of 25, which is 5. The operation between my first and second term here is a plus sign, and I square it. And then I just simplify my right side. So a negative 10 plus a 16 plus a 25 gives me a 31. And then we stop because this is in standard form. I'm going to have you pause the video and you're going to try C and D on your own. Here's your answers for these two. Pause the video again and try the next two.